carry out this illusion. They, you know what I'm saying, they want to keep working. They want to work for 40, 50, 60 years and retire. I ain't got time for that shit. You know what I'm saying? There's a higher purpose that's beyond that, traditional reality.
I totally agree. Like, I think you have put on a video that was saying that chosen ones are not meant to work a 9 to 5, right? Like, we're not be stuck behind a cubicle or a computer sitting at a desk. Like, we're not built for. You gotta realize that God, you are a generator, operator, and destroyer of your reality, right? Like, your mind creates this reality. They know how powerful you are. You have to tap into this, and when your DNA starts activated, I'm telling you, matter of fact, family, listen, you got to ask yourself this question, right? What would you do if money did not exist? If it did not matter, what would you be doing with your life? Y'all can comment below and let us know. But just ask these questions. Ask your friends, your family. Like, this is a conversation starter, so people can start to shift their mind around. What would I be doing if I didn't worry about money? What if money didn't exist? What would I be doing? I remember I asked my Uber driver that. I always have the best conversation with my Uber drivers, yo. I remember one time I just asked him, I'm like, what would you do if money didn't exist? And he was like, yo, nobody ever asked me that question. I never thought about that. Like an older dude, he was probably like in his 50s. And he was like, yo, this really changed my mind. He was like, now I'm really starting to think, like, what would I do if money did not exist? It really changed your whole paradigm. So do that, family. Think about that for a moment. What would you do?
That's crazy that you said that, because
all right, really Siri, turn the TV off. That was interesting, right? We got what, 5 seconds before time? 4, 3, 2, okay. Let's see. Okay, yeah. So that was a video I was watching. Content creator by the name of BDL1014. He talks about like esoteric. He's an engineer, but he studies. He's young too, brother. He studies like metaphysics, and, energy, and like just different stuff. And so he had a special guest on one of his latest presentations, and the special guest is Conjure Queen, a sister. She just it was really interesting though. But it's a lot of metaphysics and stuff like that. So take that a little bit. But I thought that was an interesting question that they posed right before I stopped the video. If money didn't exist, what would you do with your time? All right, what would you do if money didn't exist? So I thought that was an interesting question. Let's see. So 1, 2, 3. Okay, so today it's basically a homework session for section 1.5. We're just going to go through as many of the homework questions together as we can. As usual, if you have questions, feel free to either put it in the chat, put it in the Q&A, or I think you can unmute yourself today. I don't plan on using. Mr. Gates, did you have a question? I didn't plan on using my microphone. So let's just kind of go ahead and hop into it. Let's start with question 13. All right, so this question, let's go with this. This comes from section 1.5. This is question 49 from the back of the section. I write an equation for a function that has a graph with the given characteristics. It's a parabola, but it's upside down, shifted right 5 units and up 3 units. Okay. Yo, so I'm totally on these tangents. Like I basically, every morning I wake up around like the 3 o'clock hour, 4 o'clock hour, something like that every day, no alarm. And so I'll just turn on YouTube and start watching like conspiracy theories. What was the one I wanted to mention? They said something that was interesting. I meant to say it and it slipped right out of my mind. Yeah, I'm gonna give myself a few seconds just to see if it comes back. Hang on. It was him. What was he talking about? Oh, wait. It was about that. Education. Oh. What about that? Oh, okay. Yeah. So the question that they posed that was really interesting, they said, why weren't we taught how to grow food in school? When they said that, I was like, yes, that's something that's useful, right? because he was kind of griping about mathematics, which I totally understand. This is something to me. This narrative is if you're in like planning or construction or like working through systems. But I'm like, we go to school for these 12 odd years or longer, and they don't teach us the basics, like where does money come from and how does it work? Like the things we need to actually survive. Why aren't these things taught? They tell us that we're force fed a bunch of stuff that we're gonna forget and we don't need. They teach us just enough, like the things they were saying in videos, that they teach us just enough so that we can like run their machines as workers, but they don't teach us enough to where we can be independent. I thought that was a great point, because I totally resonate with that. I know it could take my job away from me, but it's like I don't care. Like the whole point of it is to be able to do for yourself, where you don't need the money, because you can do everything yourself. You can defend your land, you can work the land, you can protect it, you can communicate. So I feel like if people are empowered and people are able to take care of themselves, to me it's worth it. So I thought that was a great point. Why aren't we taught how to grow food? Why aren't we taught how to take care of ourselves? Everything is so you can be an employee, right? A cog in the wheel. Okay, so back to this, all right? This it's I kind of struggle with it. I mean, this stuff, don't get it twisted. This stuff is powerful and it is useful, but I don't think everybody needs it. It's when we use it, like we use it and we don't even realize it. Like how we're communicating, we're using these devices, these computers, these tablets, these iPhones. So you have wireless signals, you got power, you got the internet, like, and so to have these operations run, the conversations that we're having are the underlying like algorithms at play uses this stuff. You can't have all this technology without using the mathematics. So the mathematics is inherently there, but we use it without even thinking about it, without even realizing it. Now, I feel like if you wanted to create your own, communication system or your own cell towers or whatever, or, you wanted to create a system, then once you start getting into that realm of creation, not that you necessarily need this, but if you know it, it helps, right? That's how I feel about a lot of stuff. So anywho, okay. So we have a U-shaped curve. Let me see. You guys okay? Oh, see, you're okay? I'm gonna mute you. I think you're okay. All right. So we have a U-shaped curve. So if it's upside down, so that means that we multiplied the outside by a negative. Okay, so they all have the negative, so we're gonna let that be. Let me launch the poll so I can poll the audience. Polls and quizzes. We want the general multiple choice and launch, right? So which option do you think it is? Is it A, B, C, or D? Well, I kind of talked through it. So we know it's a parabola. There's a negative on the outside. Now, if we shift it right 5 units, that means we need to subtract 5 on the inside. So it should be either C or D. And then 3 units up. Okay, I'm going to submit my results. I'm going to close the poll. Okay, I see you. We got a few people. I'm going to keep it open over here. Okay, so I close the poll. I agree. It's the same result I got. We're going to submit that results. Check. Nice. Okay. Generate. Come on. All right, we can do the first one. That's fine. Let's zoom out just a little bit. So like, this summer, I finally started like practicing like gardening, just working land, collecting seeds, like watermelon seeds. Like, we buy this produce like every day, but like one watermelon comes with like hundreds of seeds. So from one watermelon, you can produce hundreds of watermelons. It's just, you got to take the time to figure out how that system works, and then work the system. But we're basically being paying for free stuff all this while. Anywho, describe the transformations that produce the graph of G and H from the graph of F. So F is a square root function. So notice for part A, we added 3. Let me relaunch the poll. Relaunch, okay. Relaunch. So how do we get G from F? Notice the +3 is on the outside. I'm going to submit my result. So just take a moment. What do you think? What do you think the result is? Let's take 20 more seconds. Outside, so it should be. I'm going to go. Okay, I think I see some takers. What do you think? What do you guys think? Let's take a few more seconds. Okay. All right. I'm gonna close the poll. Okay. I think I'm gonna go with the majority. Let's go there. Check. Okay. Let's relaunch. So for part B, we subtracted 5 on the outside. So let's just take a few. You guys are getting fast with it. Notice the 5 is on the outside. Okay. Let's get a few more. I'm going to go with this choice. All right. And we're going to close the poll. Okay. So outside manipulations typically cause a vertical change and they follow our intuition, right? So if we subtract 5 on the outside, it should go down 5 units. So I'm going to submit that result. Check. Okay. Let's generate. Let's go to question 20. I think it's the last question. It says in the given graph, the temperature in degrees Fahrenheit of a home is given as a function of time in hours after midnight over a 24-hour period. At what temperature is the thermostat set during daytime hours, right? So it looks like, what is that, like about 10 o'clock? It's okay, you're good. Yeah, I know. Let me see. I'm going to suppress this for now. So during daytime, if that's 64 and half, and the other one is 68, so halfway would be what, 66. So then maybe 65 degrees Fahrenheit. Let's go 65. Okay. The thermostat is set to, what temperature is it set overnight? Let's see. So if that's 52 and that's 56, halfway would be what, 54? So maybe 55 degrees Fahrenheit. So the homeowner reprograms the thermostat to T of T minus 5. Notice that minus 5 is outside of our base function, right? So let's recap. Outside manipulations generally cause a vertical change and they follow our intuition. Inside manipulations typically cause a horizontal change and are generally the reverse of our intuition. Okay, so if we subtract 5 on the outside of our function, that's going to move the entire graph. It should be down 5 units, right? So that's going to drop the temperature by 5 degrees. This will move the temperature, no, not earlier, not raise, lower the temperature by 5 degrees, okay? All right, hopefully that makes sense. Okay, sure, I'll do it. Yeah, if I can get it open. Okay, let's relaunch. All right, so which graph shows T of T minus 5? Let me see. If our daytime temperature was what, 65? So now the daytime temperature should be 60. Should be 60. I think the only one that has a daytime temperature at 60 is this one. Okay, I'll give you a few more seconds for you to decide. 2, 1, okay. All right, so let's see. 60 is this one. Check. Okay. The homeowner reprograms the thermostat to T of T plus 4. So we said outside manipulations cause a vertical change and they follow our intuition. Inside manipulations typically cause a horizontal change and are the reverse of our intuition. So notice that this plus 4 is inside the base function. So plus 4 is to the right, but again, it should be the reverse of our intuition. So we need to move it left 4 units. So then that should be 4 hours earlier. 4 hours earlier should be the first one. You're good. Okay. All right, let's keep it going. All right. So if we're going 4 hours earlier, let me relaunch the poll. Okay. So which one of these graphs shows that it's 4 hours earlier? So our daytime temperature needs to stay at 65. So I think that eliminates A. And it also eliminates D. I think that A and D don't show a daytime temperature of 65. And so then 4 hours earlier, let me see, that just needs to move to the left. So, okay, I got my result. I'm going to go with this one. Yep, that's so good. Okay, so yeah, I agree with B. Let's go with B and give it a try. Okay, was that it? Okay, let's generate. We'll do question 8. Okay. So here we're asked to graph the function using basically transformations. So we got this negative x cubed plus 12, right? So first we want to identify our parent function or our base function. The parent function here, not that one. It's x cubed. Then we multiply the negative on the outside, so it should flip it top to bottom, and then we move the entire graph up 12. So I'm just going to click to enlarge the graph. Our cubic function is third row left. I'm going to click on that guy. I'm just clicking randomly in this open cell, and I want to capture the transformations. Okay. So first we said we flipped it vertically, so we're going to reflect over the x-axis, and then a vertical shift up 12 units. I think that captured it. Okay, I'm going to check. All right, I think we did one. We'll just do the one after the next one. Describe the transformations that produce the graphs G and H from F. Okay. So let me relaunch this guy. And let me make it so that you can see the question. Okay. So F is the absolute value of 12x. Okay. So that's essentially the absolute value of x stretched vertically by a factor of 12. The only reason I'm saying it's vertical, because you can rewrite this, right? The absolute value of 12 times x is going to be the same as the absolute value of 12 times the absolute value of x, which is the same as 12 times the absolute value of x, right? So basically, I just kind of pulled that 12 outside the absolute value. Okay. So, but we have our parent function, which is basically a tall, skinny v, and we multiply the negative on the outside. So multiplying a negative on the outside is going to cause it to flip vertically. Let me see. Okay, so I'm getting this result. Okay, I'm going to go ahead and end the poll. I feel good with that. Check. Okay. Describe the transformations that produce H from F. Okay, let's see. Relaunch. Let's just take maybe like 30 seconds. What do you think? If you got the first one, then you should be able to get the second one. Okay, so I'll just give you a few seconds. Ooh. Okay. So let's talk about it. So the second one, we multiplied the inside by a negative, right? So that would cause it to flip horizontally over the y-axis, and it would really just produce the same thing, right? So let's go with this result. Close the poll. And go here. Okay. All right. Let's generate. Okay, we can do the next one. That's fine. Sorry. Describe how the graph of the following function can be obtained from one of the basic graphs. So we have our reciprocal function, which is basically 1 over x. So, and we multiplied the outside of our base function by 10. So that should cause a vertical stretch by a factor of 10. It should be the graph of the reciprocal function. We want to stretch it vertically by multiplying each y value by 10. Okay. My energy is shot, and I don't even know why. Probably because I've been up all night. Why are you keep giving me the same numbers? Yeah, what's this about? Generate. Okay, let's go to question 9. I don't know why it does that. Okay. Use transformations to graph the following. Okay. So the parent function is a squaring function or parabola. I can see 1, 2, 3, 4 transformations at play here. Okay. I don't really need this right this second. I'm going to open this up and make it so we can see. Okay. So our parent function is a parabola. So I'm just going to choose the parabola tool. I'm clicking randomly. Okay. So how many points do we need? We need 2 points. Let me see. So we can track the vertex. I'm going to start by positioning my vertex, all right? So normally the vertex starts at the origin. But this says the graph moves right by 3 and down by 4. So that should be the coordinates of our vertex, right 3 and down 4. So I'm going to drag this to 3, -4. Okay. And we know it's upside down. Let's just plot the point when x is what, 2? Okay, so when x is 2, we get what? -1 squared, which is 1, times -3 is -3, minus 4 is -7. So when x is 2, y is -7. So I'm going to drag the second point to 2, -7. Right? So if you think about the transformations, we had a U-shaped curve starting at the origin. We went right 3. We stretched it vertically by a factor of 3. We flipped it upside down, then we went down 4. And we got this image. Okay. Hit save and check. For application or for like submitting our result in Pearson, we plotted the vertex, right? We just went right 3 and down 4. We put a point. And then, normally 1 off of the vertex is usually fairly simple to calculate. So I just decided to go left by 1. So if the vertex occurred when x was 3, then for my second point, I chose when x was 2, found the corresponding y. And then, for this platform or for this tool, we only needed 2 points to graph. So to graph the parabola. Yeah, this is weird. Like, I guess I was sleepy, but I couldn't go back to sleep. I had kept trying, and I just was not going to sleep. But I was just awake. And then class starts, and I just like, okay, now it's time to go to sleep. I was like, no, now it's time to wake up. Anywho, 2019, 18, so let me see, 19, 18, 17, 16 should be here. Okay, so use this graph shown below to graph G. Okay, so I'm going to relaunch the poll. Okay. So F, we have this now, or sorry, yeah, for F, we have the red that's given on the left. And then for G, we multiply the inside by 1/2, right? So inside manipulations generally cause a horizontal change and are the reverse of our intuition. So intuitively, we might think, oh, it's a small number, so we would expect it to compress horizontally. But remember, inside manipulations are the reverse of our intuition typically, so it should cause a horizontal stretch by a factor of 2. Okay, so I think there's only one that caused a horizontal stretch by a factor of 2. Okay, I'm gonna close this out, and I'm gonna go with the majority here. Okay. Let's go to 18. Okay, let's relaunch. Okay. So graph is given. No formula for F is given. Okay, make a graph. Oh, okay, so we got several transformations. Okay. So the graph of F is given. We just looking at G, I see 1, 2, 3, a total of 4 transformations. Okay. So what we could do is track either that peak or that point at the origin, right? Just kind of follow it around. So if we start with F, the first transformation is going to be that -2 on the inside. Whenever we have multiple transformations in one function, the recommendation is to work your way from the inside to the out. Start with the innermost nested transformation and then work your way out. So the innermost nested transformation here is the -2. That tells us we should move the graph to the right by 2 units. So that origin point will go right by 2, and ultimately it will be upside down. So it can't be B or D because those have the wrong orientation. Okay, it could be either A or C. Let me see, we went right 2, then we multiplied the outside by a third, so that's going to cause a vertical compression by a factor of 3. We're going to compress it by a factor of 3. What's the difference? Did we go up 4? Okay, I can get down with C. I'm going to go with C as well. I think the problem with A did not go up and down, right, to capture the vertical shift. Okay. Generate. Let's go to question 10. I'm struggling. Okay. Sorry. Relaunch. I guess too early to be this sleepy. This is generally my round. Okay. So begin by graphing the absolute value function and using transformations to graph G. I see 1, 2, a total of 3 transformations. Okay. We're starting with a V with the vertex at the origin. We go right 1. Okay, so it has to be either B or D. We should go what? Right 1, go upside down, and then down 2. Oh, B didn't. I don't think B went right by 1. All right, so I'm gonna go with D. That's kind of hard to see though. I probably should have like expanded those so you can see it better. Okay. I think we did 18, so we'll just do we'll do 19. Let F be the function. Let me see. What do I have that I can use? Use this. Nope. Oh, no. Sorry, I didn't want to be sitting down. I felt like sitting down, looking down was kind of making my, where the head goes, the body will follow. Where the eyes go, the head will follow. So I felt like I was looking down too much. So I was like, okay, I need to stand up and look up so I can get up, right, to raise my energy. Let F be a function associated with the employee number X of each employee of a corporation. So I'm standing. I put my tablet on. I set it up on kind of like a little makeshift tower. So that I can stand up. So I got this idea because sometimes, even when I'm gaming, I'll do this. Like, I just don't want to be sitting down, but I want to keep gaming. So I'll sturdy. A little bit better. Okay, that's fine. There we go. Yes. Now I'm at my virtual podium. I get to stand up. Okay. Let's see. So let F be a function that associates the employee number X of each employee of a corporation with his or her annual salary, F of X in dollars. The number of each employee with their salary, the salary is F of X. Suppose each employee was awarded $500 across the board raise and an additional 2% of his or her increased salary. Write a function P of X to describe the new salary. Okay. So let F be a function associated with the employee number. So, okay. $500 across the board raise. So if F of X is their salary and they are awarded $500 across the board, so whatever their salary is plus 500, right? So let me capture that here. I think actually I'm gonna get rid of this. No, use this guy over here. So the salary is F of X. Let's go like this. I'm just going to take my notes here. So their salary is F of X. And then we're going to take their salary and add $500 flat, right, across the board. And then from this new number, an additional 2%. So we're going to add 2% to this. So if this is our new 100% and we add 2%, then we're going to finish with 102%. So we can capture that. So we can capture that by saying I'm multiplying this new number times 1.05. So I'm going to do 1.05. Sorry, 2%, so 1.02. And we need to distribute. Because we're saying that an entire new salary, if we want to increase it by 2%, right? The F plus 500 was the 100%. And then 100% plus 2%, we need to finish with 102%. So that's why I multiplied by 1.02. Type an expression involving F of X. Type your answer in slope y equals mx plus b or slope-intercept form. Do not include the dollar symbol. So we need to distribute this 1.02. Okay? We need to distribute this 1.02. So then we're going to get 1.02 times F of X plus, let me see, 10% would be 50, 1% would be 5, so 2% would be 10. So it looks like it should be 510. Okay, you can verify that with the calculator. So now I'm gonna get rid of my notes. Okay, so this is the result we got. Cross our fingers, we're gonna hit enter. That is good. All the time, right? Okay. Okay, not bad. Yeah, I feel so much better just standing up. Like, yo, that was because I was like, and it was weird because leading up to class, like plenty of energy, I feel good. I'm like, yeah, let's go. I'll take naps and stuff like that. And then as soon as I sit down, I'm looking down after about 5 minutes. I just want to put my head down. I'm like, and I know it's my body physiology. It's because I'm looking down, sitting down, everything's pulling down. So I built this little tower so I could stand up, change my a lot of times if you want to take charge of your mood or your physiology, change your position. If you want to take charge of your mood, change your physiology. In other words, like if you're feeling a certain way, just get up. Just change your body position and you'll start to feel better. If you want to like seem lighter, raise your eyebrows. Like, you know, it's weird, but like if you raise your eyebrows, it kind of raises your energy a little bit, right? So anywho, okay, so we did this one. We got a solid 10 minutes. Let's generate. We'll go to question 7. It's 3, 4, 5, 6, 7 is here. Yeah, that totally helped. I feel so much better. Okay, so graph the function by starting with the function from the library of functions and then using transformations. Okay, that's fine. All right, so our parent function here looks like it's a parabola, x squared, and I see two transformations at play here. Okay, so I'm going to click to enlarge the graph. Hopefully we can move this so we can see. All right, I have to suppress this for now. Okay, so now we can see. So parent function is a parabola, so that's the top row right. I'm just going to click randomly. Okay. So then, again, if we're doing multiple transformations in one function, the recommendation is to start with the innermost nested transformation. So we will start with that -3 on the inside. That means take your parent function, move it to the right by 3 units. So horizontal shift of 3 units. I'm going to drag this to 3. And then +2 on the outside. So that should move the entire graph up by 2. Okay, did I go 2? No, I didn't. Okay. That looks good. So it's a parabola. We went right 3 and up 2. We're going to hit save. Check. Okay. It's much, much better. Generate. Let's go to question. I know we did this one, so we'll adjust. We did 18, 19, and 20. We'll go ahead and do this one here. All right. So graph this function, same deal, right? It's a parabola, and we only have one transformation where we have that -6 on the outside of our base function. So U-shaped curve, I click randomly, and I want to do a vertical shift down 6 units. -6. Save. Okay. Check. So time. Okay, let's generate. Let's see, have we done question 6? That was what? 4, 5, 6. Use transformations. Okay, so a V-shaped graph. The -3 is on the inside. All right. So which way should it go? Let me launch the poll here. Yeah, pretty good sized house. Polls and quizzes. Launch. Okay. So how does, okay, good. Let's see. Absolute value, -3 on the inside. It should go right by 3. I can get down with that. I'm going to close the poll. I'm going to go with the majority here. Okay, nice. Generate. Let's see, question 11. So that was 6, 7, 8, 9, 10, 11. Okay. The greatest integer function. So the greatest integer function, we call it the step function because the final graph looks like this stairs on the staircase, the steps on the staircase. The greatest integer function is going to be the greatest integer less than or equal to our number, right? So if we get an integer, that's just going to be what the answer is. If we get a decimal, the way you can kind of crunch any of these specific points, if you get a decimal or a fraction, if you plot that decimal or fraction on the number line, you're going to take the integer to the left. So if it gives us an integer, we just take that integer. If we get a number between integers, you take the integer to the left. Okay. So stepwise function. right? Normally it starts at the origin, like the origin is filled in and 1 is open, you know. So, but basically this is saying we go right by 1 and then do a vertical stretch by a factor of 3. So we know it can't be A or B. I'll just finish it out. It can't be A or B because those that are a vertical compression, it needs to be stretched vertically. And then I think the only one that went to the right by 1 is D. So we're going to go with that. Got a few more minutes. Generate. So that was 11. So we'll go ahead and do this one. Write the function whose graph is this, but shifted to the right by 4 units. Okay. So parent function is x cubed. Now I'm going to kind of type it like this. I'm going to do my parentheses to the power of 3. My x is here. But it says we want to go to the right 4 units. To the right is the positive x direction. So in order to capture that, we have to put -4. Okay, that should be it. Let me hit enter. All right, how many questions? What do we have left? What's the time? We might be able to finish. Graph this function. So square root, let me relaunch the poll real quick. Relaunch. If we can do a quick draw. You got any quick draws? Let's see. All right, I'm gonna close it. Let's see if that's correct. Okay. Let me talk through it. So square root of x is the top half of a sideways parabola starting at the origin. That +3 is outside the base function, so it should move it up by 3. And I think that a is the only one that went up by 3. Okay. Okay. All right. What else do we have? 2 more. 3 more. All right. We got a little bit of time. Write an equation for a function whose graph fits the description below. It's x cubed shifted 4 units left, stretched vertically by a factor of 5, reflected horizontally, shifted 2 units up. Now we might make a mistake here, but what I'm going to do, so I'm going to do something similar to the previous example. I'm going to do my parentheses to the power of 3, okay? And I have my x. So I pretty much rewrote f. I just put the x inside the parentheses. Now, the first transformation, it says it shifted 4 units left. So that means we need to say +4 on the inside. Stretch vertically by a factor of 5. So that means we're going to multiply the outside by 5. Reflected horizontally. What I'm going to do is just put the negative here like this. It gets a little bit trippy, but I'm just going to go with this. If this doesn't work, we can adjust. It then shifted 2 units up. So we need a +2 out here. Okay. What else do we have? 2 more, and then we'll call it a day. Use the graph to graph the given function. Okay, so basically just take the given graph. That +3 is outside the base function. So we're going to move the original function up 3 units. Let me relaunch the poll real quick. Hopefully we can get a quick draw. What do you guys think? Which one is captured by this? You can go. Let's go. Let's go. Let's go. What do you think? All right. Again, the +3 is on the outside. Okay, I'll go with it. Check the answer. Okay. All right. One more. Right here. Okay, so not too terribly bad. +2 on the inside. Let's relaunch. Which one captures +2 on the inside? What do you think? +2 on the inside. The others going once. Going twice. I think it's the same people. Okay, we got another one. Okay. I resonate with it. Let's submit it. Are there any burning questions before we go our separate ways? So this one wasn't too terribly bad, right? I mean, we did the homework together here. We did it in 50 minutes. That's reasonable, right? So hopefully you've already done this section. You can kind of chill. Hopefully, honestly, you can actually go ahead and do all the homework and quizzes for the entire semester. And then that way you're only waiting on the exams. That's your prerogative. I would personally do it, and you also have access to our lectures for the entire semester, so you don't really have to wait on me. You'd only have to wait on me for attendance and the exams. Okay, but aside from that, if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. Next week we're going to do section 1.6, and then we'll be ready for exam 2. All right, guys. Take care. Have a great weekend. Peace.